Okay. So this is your assignment instructions for exercise 1. You can read the goals for the assignment. They're basically for you to function and do some gameplay programming, ranging from fairly trivial to fairly complex within a vertical slice environment with a bit of complexity to it. Now, we went over a lot of that complexity today during class, right? We have animation trees, we have sound effects, we have all sorts of buses going on, we have signals, we have a variety of scripts all interacting together. So in this system of complexity, you have 4 stages, 4 goals to complete. And here is the rubric. Stage 1 is worth 10 points. Stage 2 is worth 30. Stage 3 is 15, and stage 4 is 15. This is a progressive grading system. The earlier per really unit of your work is rewarded more by grades on the first 2 stages than the last 2. Now, there's only 70 points here. The 30 points that are left are going to be for peer reviews, which we will start next week. And on next Tuesday, I may do it this Thursday, in one of our upcoming next 2 lectures, we will go over peer reviews and what are good peer reviews, what are bad peer reviews. If you want to get a head start on that, you can look inside the course repo and look at the peer review section. You'll see the templates that we used for last year's repositories. So they'll have some Unity speak in there. The gist is still the same. You can go through and look at some of the graded ones. There's an example of a really good review and examples of maybe not so good reviews. Right? So I wanted to give you a sense of like where grades were given what reviews look like and contain. Right? Some pre-graded examples. Okay. The command pattern. So the command pattern is the heart and subject of exercise 1. The command pattern, there we go, we'll get the microphone adjusted well. The command pattern has this at its core, the command class. So this is just like we talked about in class last week. The command pattern is a strategy or a pattern to help you decouple actions or commands from where they come from. At least that's how we use them in games predominantly. So a quick example is you press a button, instead of in an if statement, that button press being hard bound to moving a character left or right, or selecting an action, or shooting a projectile. Now there's a point of abstraction. We've broken a hard link and made it a soft one. We've made something that is set at compile time to something that can be changed at runtime. This is what command gives us. So the command has 2 parts that are important for us right now. The big important one is execute. Execute takes 1 parameter, a character. As a reminder, the character is the heart of all of our 3 major characters in the Rut project in exercise 1. We have the player, the follower, and the boss. All of them are characters. So execute takes a character. The character is the one performing the action. Instead of character, we could call it performer or actor here. You can use that synonymously. Next, we have this status. It returns a status. A status is our way of signaling 2 things that enact the command, whether the command is currently ongoing. You'll see in previous examples that we used that we returned a Boolean, true to denote active and false to denote inactive. Well, this is more rich. You have a more rich information channel to pass around. Particularly, there's errors that happen, and you want to be able to flag those. Perhaps you want to run the action again instead of just stop. Perhaps you want to know why something failed. Perhaps there's an out of range status that you want to put on something. Right, so we use an enum for this. Enums are great because they are a little more reliable. You get some static type protection for them. They're a little less brittle than using raw strings. Even though we do have entered strings inside of Godot script, GD script, which is great. Can anyone tell me what entered strings are? Has anyone encountered these? So there are strings where an entire string is stored as a memory location. So basically every string you make is a mini const. And therefore when you compare two different strings, it compares a memory address instead of going character by character and doing a long comparison. So you trade off some memory for rapidly fast and righteously fast or efficient string comparisons. So strings become int comparisons instead, or reference comparisons, instead of by character ones. So it's kind of neat. And when you pass strings around, you're not passing around a chunky data structure or a brittle pointer. You are passing around a simple location, which I guess is kind of a reference. All right, so this is our major point of decoupling. All of the commands, jump, move left, move right, summon, all of these commands are in some way inherit this command class. This is the closest we get in GDScript to having an abstract class. How many of you used abstract classes before? Or virtual classes? Classes with virtual members. Okay, so we have a few. Right, can anyone tell me what their use case is? Yeah?
At least in my experience, is to like kind of define something that's a little general, and then like you have another class that extends that abstract class that's a lot more specific.
Exactly. It's meant to denote general capabilities that many classes can rely on, just like our command class here. Usually there is a singular capability that abstract or virtual classes prevent you from doing, and that is calling new or instantiating a version of it. They're not meant to be used by themselves. They're meant to be platforms for other classes that can be instantiated to be built from, right? So that's what we're doing here. Although there is nothing preventing us from using command, which is why we also have it just do status.done. We use it as a dummy command for when we want nothing to happen. And you can see that in the unbind, in the player script, the player's controller, where it has bind and unbind commands. And when you unbind the commands, all that it does is take all of those command variables and assigns a new instance of this blank simple command to it. All right, and we talked about this in class before, just earlier. So this is sort of like the beating heart of a command queue. So when we covered commands previously, we didn't go into their better, more comprehensive game use case. And that is to provide a set of actions that can happen sequentially or in parallel if you want to go even further. We just have a simple command queue or command list that we're basically treating like a queue in this instance, right? So you can see this simple bit of code here goes through a command list. While there's something in the command list, it'll execute whatever's on the front of the list. And then when that thing returns done, we pop it and go to the next one. If that was the last one, the next time we go through here, we simply play an idle animation because we don't have anything else to do. And this is the one cardinal sin you must not commit when making NPCs in video games. They should not sit there having no animation. They should not sit there being completely blank and not actually performing. Like dead air time in radio. All right, so all this is to sort of like, we'll go over some of the commands and how they're used in just a moment, but I want to do a basic overview of what I'm asking for you for this assignment. So first, stage one, jump to it. So you need to create a jump command class. So you have a lot of command classes to look at to do this. Good do. Okay, great. Now I can get rid of this stuff. All right. So if we go to our scripts, well, let me do this. Control-Alt-O brings up the script search, and let's look at attack. I can't actually read the letters from here. I think that says attack command. All right, attack command. So attack command extends command, and it implements the execute function. And the signature is the exact same as command. And you can always go up to one of these, right click and look up symbol, there's command. I simply copied and pasted in the instructions. All right, so we set attacking to true. So we had that set of variables inside of player, and those variables helped us control the animations and physical aspects of what was going on with the player. So attacking equals true, that is actually picked up by the player class, and then we do a couple things. We set the flag for attacking being true in the animation tree. We set that to true, and then we turn attacking to false. So we had a little toggle here that we talked about to handle the temporal nature of attack. So that's what happens here. We also do call the command callback, so the sound system can then play an attack sound from the attack playlist, randomized playlist, and then we return status.done. This is not a durative command. This command takes no time. This command is meant to be used by the player for player input only. So we use an attack command, the animation happens. This is not a blocking or durative command because we want the player to be able to move around during the attack animation. We don't want to have animation lock where you're sitting there static, still, can't move, can't jump, can't do anything while the sword swings. We take care of that in the animation tree in saying, hey, this animation has to play to its entirety before the state transitions to another animation. Right? So we have a dual nature here of temporality with player commands, and that's tricky to get right. This is one of the trickier parts of game development, is like handling this set of consequences. How do you want to design this attack? If you were, let's say, programming the original Castlevania for the NES and the arcade machines, you could have made a decision where your jump command is uninterruptible. The only thing you can do is swing the whip while you jump. So if you play some of these old games, particularly Castlevania games, when you jump, the arc is set. You cannot alter that trajectory after you leave the ground. It's actually like, jumping in real life, without jetpacks. But I decided that was not the look and feel for this game. I decided that's not the player experience I wanted. So this is the implementation consequence of that. But your goal is to make a jump command. So if you look inside the code and you search for stage 1, I put in a few tags, comment tags, like stage 1, stage 2, stage 3, stage 4, inside of files in this template repository for you, so you can check them out and have a little bit of hint on where to start. But for this one, you should make a whole new class that extends command called jump command. And inside of execute, you should do the jumping. And you should also, and I give a hint inside of here that you should put this line in as well so the sound happens. If the sound doesn't happen, it's not the end of the world. That's the only thing this call would do. Right, so create a jump command that extends the command class. The command should properly check to see if the player is on floor. Now you have a reference to character, so that is simply a method the character has before initiating the jump. You need to provide an appropriate jump velocity that is consistent with the player class so that the player can jump over the obstacle in the level. That is that first platform to the right of the tree. Additionally, you are required to create a jump action in the project's input map, which I think I kind of left in, so you may not have to do that, where space up or W is pressed. I know I did not put in the up keys, up, down, left, and right keys. Feel free to add those if you'd like. If you'd also like to play this with a controller, feel free to add a controller button there too. So, jump. So you can look at attack and the attack command and the move commands to get some information, some pattern for how to make this jump command. You also need to put the jump command, you have to put it in the input map for the player. So in that bind input function, bind player input commands, make sure jump is in there, tagged appropriately. So this one should be pretty straightforward. I'm giving you a real easy one here to get started, to get the assignment rolling. FPS, right? First problem solved. Stage 2, a best friend. I didn't do a whole lot with the follower. I wanted to leave that a space for you to play and be creative with. If you do things above and beyond in this assignment, I traditionally give bonus points and extra credit or participation codes for people who go over and beyond that show extra mastery. So if you want to make the follower even better than I ask for here, that's a potential way. All right, so I want you to create a follower controller. Alternatively, you can just call it follower so it matches the pattern of the other controllers, player and boss. I will accept both follower controller and follower. So this should extend character, like boss does and like player does. And it should, the extend character will give you the basic physics options like player and boss had through the character class. So there's the physics process that you can put your game logic into. There's a ready function where you can set the movement speed and jump velocity for the follower. And I'm asking you to put in a little bit of logic for the follower. So when you're within, let's say, 5 units or 5 pixels of the follower, basically you run right on top of them. The follower should be like, hey, I want to follow this awesome adventurer. That's where your new follow command, that second large bullet point, comes in. You should make a follow command that, when called in every physics update, should follow the player. So you have a notion of where the player is, you have a notion of where the follower is. Make the two meet, go towards the player. They should also have a maximum tether, so if the player gets too far away, the follower is like, oh, I don't know, I'm lost, and doesn't follow anymore. The follow should break or return done. Now, a hint here, and you can look at some of the other commands to do this. You can use a constructor. Notice that all the commands we've looked at so far, they take a single character, right? That would be the follower. Where does it get information about the player? Well, you can have, more information inside of your commands than what the execute function provides. If you want a follow command to follow a player, you should use a constructor, underscore init. You can pass in whatever you want with underscore init, including a follow target. And you can store that in a local member variable so that when execute is called, every process, you can then look at the current position of the target to follow, and you can look at your current position of the character, which is the follower, and move towards it. I'm also asking you to call a jump command when the player is higher. When the player's y is higher than the follower's y, you may want to add in a little buffer there because the player is naturally taller than the follower. So its center is a little taller. So just when they're both standing on the ground, the player's y will be taller than the follower's y. So it would always jump. So you want to add like maybe a 10-ish pixel buffer or 20 pixel buffer so that only when the player gets substantially higher than the follower does the follower then jump. The idea there is we want the follower to be able to get up the stairs to be in the boss room with you. All right. You can reuse the jump command that you made for your player. Have the follower simply call it. Here's an outline for the follower controller. There's a command list. That'll come in handy later. I'm setting you up for success here. Usually get a reference to the player. A lot of these characters need to know information about each other, so it's fine to give them references to one another. We have the ready command where you want to set some initial values, such as the velocities or any state that you want to keep, such as is jumping. And then we have the physics process for you to deal with the logic of the controller. So when I say controller logic here, I know the term's a little overloaded. I'm not talking about the physical controller and handling inputs coming from it. We're talking about the mind of a follower. What does the follower want to do given the game state? And don't forget to call super delta. So super delta, as a refresher, calls the physics process function from the parent class, aka character, where all the physics stuff happens, where move and slide and gravity is applied. All right, any questions about these first two stages? These are meant to be a little more straightforward, just to get you into the project and get you programming things, working with the command pattern, building a basic controller. I'm hoping that there may be some questions about logistics on these, but this should be within most of your capabilities to do quite readily. Now we're getting to some things that are a little more difficult. Death by 1,000 cutscenes. So what we have are some voice lines, we have some creepy elk noises, we have a Genshin-inspired bright forest landscape, but we don't have a lot of actual character or narrative content. We have the things that the player says, but they're little flavor callings more than anything else. Now, what we want is a little cutscene for you to tell a bit about the world. I want you to involve all three characters, the player, follower, and the boss, in this cutscene. Each one of them should have their own command list. Or they should have a command list applied to them, and we'll talk about that in just a moment. Now, each one of these characters needs to be acting during that 20 or 30-second cutscene with their own set of commands. You can't just have one character act and the other characters do nothing, right? So each one of them has to have a command queue that lasts through the cutscene. Sometimes they may just be idle while other characters are talking. You may have an elaborate dance where they all move together. This is about you structuring the commands in command list over time to tell the story. The control is completely in your hands as the game designer here. There will be no player input. Everything will just be scripted. Controller, hands off controller. And I'm not letting you skip this cutscene. We're gonna watch these. Right, so what I'm asking you here is to engineer one of these cutscenes through using a bunch of commands, understanding how they work, understanding the game flow. This reinforces how controllers work and how the command pattern applied more rigorously to games works. All right, so there's a few things to note here. I will be rating you on the number of unique derivative command types that you use. So we'll take a look at derivative commands in a moment, but you have moving, you have jumping, you have putting up a dialog box, you have attacking. You have a lot of different affordances to use. So you should use a lot of them. Maybe 8. I think I give you 7, so you may have to make one. And then we'll see how well the synced the three characters are to one another. That's more of a minor concern. We'll also want to see how good the transitions are from you getting into the cutscene, then from the cutscene progressing to stage 4, the boss battle. And the better tail you give, the more potential bonus or participation code or rebate points on this project you may receive. I've even given you a little class to help with this called the Cutscene Manager. So the Cutscene Manager, you could have references to each one of the characters, to each one of the player, the follower, and the boss. I commented some of them out, but you can comment them in. You want to unbind player commands on the way in, or unbind them on the way in, bind them on the way out. But in the middle, this is where you want to put your implementation. So you have some choices here. You could run 3 command queues and run the physics process right in here and have all the characters be controlled by the Cutscene Manager directly. So instead of passing in self to the command argument, you would pass the character that you would want the command to be done by. So you'd have a command list, you'd have a boss command list, you'd have a player command list, you'd have a follower command list, and you'd pack those all with commands and run all of those commands in physics process so each character is animated at any given time within the cutscene. And then when you run out of commands, you detect when your cutscene is over, you move on to the boss battle. Right. So does this make sense? Does stage 2 make sense? Just looking around, seeing slow nods. Okay, all right. Slow nods. All right. Let's take a look at a couple files. So just to refresh, this is the boss trigger, right? This is called when we enter that collision area inside the boss cave. So what happens is we go in here, we detect on-body entered, and we scope the non-body so that it is the player. So this only reacts to a player class entering. We set the camera location, and notice the camera zooms around a bit. We have sort of soft follow turned on the camera attribute. So when it moves, it has a bit of slowness to it instead of directly snapping and teleporting. All right, and then we call engage. This is where the line said by the character comes in. If that line is not consistent with your cutscene, feel free to I'm not in the editor. Feel free to comment the line out. The cutscene should be your own. Maybe a command you could make is speech act. You can use those voice acting in your cutscene if you'd like. All right, and so here, what we're doing is we're going into the boss and adding a bunch of stuff to its command list in order. Here we have a summon command, so the boss goes from just being a blinking red eye, blinking red light, into a sprite. Idle, so it's idle for 1 second, and then does jump command with these velocities. These will last. Notice these say durative. We'll look at what those mean in just a moment. Durative attack, jump attack, move forward, move backwards, or move left, move right, move left, move right. Basically, we've seen this, right? The last one is the dialogue, which brings up a dialogue for that number of seconds. So these are ones I've given to you. You can use this as a basic palette. Let's take a look here and check out some of the other commands. So first, what I want to look at, scripts, commands. So we have NPC commands and player commands. The player commands are the non-durative ones. The ones that are meant to be used as player input. Notice jump is missing from there. You should put your jump command right in that folder. You have our NPC commands. And there's durative in front of a lot of these, which means they should be blocking for the time allotted. So here's the heart of this. This is the durative animation command. This is also another abstract class that extends command. It gives it a little more information. And here we are using Unity's thread-based timer mechanism. So basically this timer will spawn off an asynchronous thread that will just keep track of how much time has passed. So what we're doing here is this has a particular function that it needs to be used to set things up, where we give it a character, the animation we want it to perform, and an optional duration for how long it should perform it. So this works for move, this works for jump, this moves for attack. If no duration is given, let's just mark through here. So if there's no timer, if timer hasn't been instantiated, we know we're beginning, so we make a new timer. First, we start playing the animation that we send in. We start the timer. We add the timer to the tree so it syncs in with the process update. The timer is now attached to the child. We make it one shot so the timer only runs once and then ends. And we call the animation callback. So let's say if this is attack, the attack sound will be played. And then if the duration that we sent in is approximately 0, although we may not have sent anything in at all, so it may be the default value of 0. I guess if it's not 0, then we want to run the duration. Otherwise, we take a look. We start the timer, but we set its time to be the length of the current animation that's playing. Right? So it picks the duration of the animation as set in the animation timelines inside of the animation player and does that. So when we're attacking, it does the full 1.5 second attack animation swing. The timer is set to be that duration. When that timer expires, we're done. We return status done. Right, so this is generic to be used with any animation. If we take a look with the durative attack animation, you'll see how this works. It's a little simple now, right? We simply say, hey, manage durative animation command. Why don't you do an attack with the character? And we're not giving you a duration, so just make it the duration of the attack animation. and it sort of handles all those return values, right? So it's pretty easy to do these durative things. So if we look at durative, which one do we have here? Durative dialogue, this one's a little more complex. We have durative jump, which is a lot of the jump logic inside of here. So we want to jump until the body hits the floor. We have durative move left. So you move left for a duration. You can see over here, move left for duration. And when it's done, we stop the character. I forgot to do this. And so the command stopped, but the character kept going. The velocity was still set to a speed. One is very similar, move right. Summon command, which just lasts the duration of the summon animation. So you're kind of seeing how this works. So all of these commands last a certain amount of time and return the active status while they're turning. When they're done, they return done. So we know when to pop the queue and move to the next one. All right, any questions about these durative actions? I know I'm going a little slow and we're covering all this. I just want to make sure you all should get this implementation and understand it. Guys, once you sit there with your project open and are staring at the description for stage 1, that's when it gets real, right? Excellent. Okay. So I think stage 3 is still, this whole project 1 is meant to be a little more approachable. The goal here is for you to deal with something interesting gameplay programming wise with the complexity of an ongoing vertical slice. Okay, let's take a look at stage 4, boss mechanics. So this one actually has the shortest description. Why? Well, we've done everything that you need. So stages 1, 2, and 3 have set you up for stage 4. This is where you get to be more creative. I like putting in an open-end, more creative last stage on all of these assignments. This one is to make your own boss battle, right? With jumps, movements, attacks. You can do something basic and just make a looping boss battle that you just have to fight your way through. But I'm also giving you a chance to do something more interesting. How many of you are familiar with this classic villain of cinema? His name's Frieza, right? How many forms did Frieza have? Not counting gold. I don't remember myself. A bunch, right? 4, right? So maybe you want a stage boss battle. Maybe you want the boss battle to evolve. There's a lot of different animations unused. Perhaps you need to climb a wall to pick up an item to power up to be able to hurt the boss. Or there's all sorts of things you could do here in this boss battle. This is an open framework. This is a palette for you to be creative with, to make something fun with. And what I like doing is finding the better one of these and we show them off during class. Right? This is a way for you to be creative and use your ability as computer scientists to do something more interesting, a little more artistic, more playful. All right, so the core of this is managing a set of commands in a command list with the boss. Perhaps there could be even some internal logic that then alters the commands with response to the player. This doesn't have to be scripted. This can be reactive. Heck, you may want to make your own state machine, just like we did with the player using animation tree. Notice the boss does not have an animation tree. You could add one. There's all sorts of fun stuff to do here. But make sure you describe what you've done in a comment in your whatever file you implement your boss battle in. I recommend perhaps making a boss battle manager, or you could really make a new, more comprehensive set of functions inside the boss class itself. Wherever you do those, put a nice descriptive comment for your peer reviewer and for your grading for the instruction team to know what the heck you're doing. If you make something complex that you have to enter up, down, right, left, right, BA select sort or whatever, make sure we know about that because that will not be something we'll be able to pick up on the fly, right? let us know. Communication is key. We are not your players. We are your co-designers. We are in the same game dev house. All right. And if there are any contextual things, like, hey, you may have like done something interesting with the follower, but then didn't quite do like stage 2 as described, that's okay if you went above and beyond and like feel comfortable with what stage 2 was. We're typically pretty happy to look at those sorts of things. Now, we just need to know. So if you're going out of band on this and doing something special, put it at the top of the README above this, above programming exercise 1 command pattern, and make it like blinking, obvious. We can't miss it, right? So we want to be able to see this stuff. When do you give credit where credit's due? Anyone old enough to remember blinking marquee tags in HTML? Scrolling, blinking marquee, anyway. Old HTML was wild. Do one of those. All right. We have about 8 minutes left. I wanted to give some time for you to get started, to ask some questions, maybe to clear up your GitHub Classroom information. Those of you that haven't. 2 minutes left. This says 8:52. The clock's even off in the room. The monitor doesn't work. The clock is off. You're right. When I look at my watch, we have 2 minutes left. I didn't mean to steal your time. We have 2 minutes. I will stop talking now, and we can get to it. Please come forward if you have any questions. Happy to help. Discord is a great place to go. I will have office hours tomorrow at 11, from 11 to noon. If you want to stop by, get started. I'll have those. I'll record those. But as always, it has to be relevant before I upload them. Okay?
And I, your TA, will be hosting office hours on Friday morning. My office hours are posted on Canvas.
Nick has TA hours on Friday. Posted on Canvas. Please attend. One moment while I stop the recording.